As we continue to build a foundation for Python programming, we need to learn about one important topic, which is Booleans and comparisons. Booleans are expressions of true or false, so these are a data type, a predefined data type in Python. These become useful when we need to write functions or reusable code in the future. So we will start by setting variables equal to true and false. Notice the capitalization is important here. So I'm creating a variable, lowercase t, setting it equal to the value true, which again is predefined in Python, and then I'm setting a variable equal to false. We can then check the data types for T and F. And we don't necessarily have to assign these values to variables, but that's common practice, so that's what we'll do. All right, so let's take a quick look here. So notice that when we check the variable types for the true and false, we get back a class that's abbreviated bool. Just to make this obvious, I would like to add an additional code block and modify it slightly. Here, let's just take a look at print type, and I'm just going to enter in the variable name true. Notice it turns blue. It's not always the same in every Python interface that we use to run code, but usually a predefined data type will show up in a different color in whatever programming you're using to run your Python code. Okay, so this just accomplishes the same thing without setting the value true equal to a variable, lowercase t. Same result. There's some unusual behavior that we should know about. It's not something we'll encounter regularly, but this not so obvious behavior is worth knowing about. We can use this bool function to check the Boolean value of any expression. So for example, let's anticipate what we're going to do. We'll set a variable a equal to 0, and then we can check the Boolean value, and that will give us either a true or a false. We'll do the same thing with an empty string. So let's take a look at this. So a is equal to 0. The Boolean value associated with a is false. And that's, again, something that's predefined in Python, as 0 is recognized as having a Boolean value of false. And the same thing happens when we have an empty string or a null. All right, so in short, we can summarize any object with a 0 or null value has a Boolean equivalent of false. Any object that does have a value has an associated Boolean value of true in Python, and this is a little strange. So let's just take a look at a variable c that has a value 9. Let's try that out. So we'll set c equal to 9, and then we will check whether 9 is true or false, and we should get a true because it actually holds a numerical value. Okay, and if you're curious, you can try the same thing with a string. So d equal something like that, and then we'll check Boolean value of d, and it should give us a true. All right. Okay, so that's just some funny behavior to know about. Now, where do we use Boolean values? We often use Booleans in the context of comparisons, and there are two main types of comparisons that we will take a look at. There are relational comparisons and logical comparisons. Starting with relational comparisons, these are things that we're used to seeing in math classes. So we start by checking for equality, and basically when we write these statements, we're asking the question, is x equal to y, is x less than y, and so on. So here is the syntax, usage, and interpretation for each of those relational comparisons. So let's try some of these out. In each of these examples, we're going to go ahead and set x equal to 4 and y equal to 5, and then we'll check for equality. So obviously x is not equal to y, so we get a false. At this point, make a note of the difference in the usage here. A single equal sign is used to assign a value to a variable. Double equal sign is used to check for equality. That's really important. Let's try checking for and using an inequality. Is x less than y? Yes, 4 is less than 5. Let's try the other direction. Is x greater than y? False. No. Y is greater than x. We can also do less than or equal to, right? So that is the inclusive comparison. Of course, we will still get a true here because, yes, x is less than or equal to y. Finally, to check if x is greater than or equal to y, we use this syntax here. That one gets people stumped sometimes. They occasionally reverse the order and use the wrong syntax, and of course you would get an error if you did that. You would get an invalid syntax, and then maybe you would have to look up and remind yourself of the correct way to check if x is greater than y. Greater than or equal to y, I should say. Okay, so that's fairly straightforward. Those are relational comparisons. You can always look these up if you forget the syntax. Logical comparisons involve logical operators, and they're typically used to evaluate whether two or more expressions are true or not true. For example, they can be used to determine if a grade is a passing and that the student is registered for a course. So these are more combinations of results. And we can also check if both of those cases are true. Then the student might be assigned a grade in a system. So that's a somewhat more complex situation than simply checking for equality and inequality. Another example would be something like determining whether a user in a system is a valid active customer of an online shop based on whether or not they have store credit or have made a purchase in the last 6 months. So those are some scenarios that could involve these logical comparisons. So there are 3 types of logical comparisons, and here's the syntax usage and interpretation. So we have the not, which checks if the opposite is true. So we get a true if x is false, if we use the not syntax. The and, if we use x and y, we would get a true if both x and y are true. The or comparison could be used as x or y, which would give us a true if either x or y is true. And there are actually other symbols. There's some other syntax that can be used for these, and you could look those up. So let's try getting the hang of how this works. In the following examples, we're going to again use variables x equal to 4 and y equal to 5, and this is an exercise for you to try building some intuition for these comparisons and thinking through them and checking a box to indicate whether you think that result will be a true or a false. So let's just think about one of them. Okay, so x greater than 2 and y greater than 2. Well, we know that both x and y have values greater than 2, so that one should be true. Then we get into some tricky ones here. So x greater than 2, let's look at the bottom one, not x greater than 2 or y greater than 2. So x is greater than 2 and y is greater than 2. So this statement would be true if either one or the other were true, and so it is. The statement in the parentheses is true, but we're putting a not in front of it, so we should actually reverse the Boolean value, so that should end up being false. We can get kind of turned around, and I definitely make mistakes with these from time to time because this puts a demand on your working memory because you're having to keep track of several things in your short-term memory and kind of adjust the information as you go. So here you have the code blocks to test out your predictions, and you can see the result, right? So let's try this one, x greater than 2 and y less than 2. Well, that one should end up being false because y is actually greater than 2. It's not less than 2, and this entire statement would only be true if both of the expressions were true. They both have to be true in order for the entire expression to evaluate for true. So I'm predicting a false here. So I'll leave some of these for you. Let's just make sure we got this last one right. Okay, I'll leave some of these for you to try out as exercises. But that is Booleans in a nutshell, focusing in on logical and relational comparisons.